Fucking live, man. देखा मैंने। आई थिंक वो थोड़े डिले के बाद स्टार्ट हुआ है। देख यूट्यूब पे। हाँ वो प्रॉपर। फक रुक। हाँ, हाँ, सही चल रहा है। मेरा ही स्लो आ रहा है, पीछे आ रहा है। हाँ तो आई रही। ये इसमें आवाज क्या है? तेरे इसमें माइक है क्या? हेलो। उसमें आ रही है आवाज? ओ फक, थोड़ी देर बाद आएगी। ओ हाँ फक। सही। सही है मैं अच्छी बात। Good evening, guys. I'll stop being so formal. Today's QSTP is live on YouTube. So I just wanted to discuss some object-oriented programming courses before we start. Some concepts. I might be a little nervous and there might be some random interference. So please try to hang on. Uh, Before we begin, I hope you're enjoying QSTP. And I would have screencast myself, but I'm not looking very good right now. Anyways, before we begin, why I why I wanted to do it. I wanted to explain object-oriented concepts to you was because it's very important. It's a very important part of Python, and as we move on into developing, and as we get into developing our further modules, it'll be very helpful for us to do it through the object-oriented programming way. So before we start, let's start. Anyways, object-oriented programming. Yeah. Can you earphones? Yeah. So basically, object-oriented programming. I know if this sounds like Khan Academy or something, but yeah, that's where I got the idea. So I hope you guys enjoy. Uh, Object-oriented programming is all about using objects to represent different data functions, and to store data and so on. As you know from the definition, object-oriented programming, we define objects which helps us represent data. To give you a small example, let's say I define an object called student. That's a very basic example. So the object called student will have all the information about the student stored inside the object. So the object is a representation of the student as well as it stores all the information about the student. So that brings us to our first important topic of object-oriented programming, and that is encapsulation. Encapsulation. Yeah. Forgive me, this is the first time I'm using this. I hope it's not very clunky. Yeah. That's encapsulation. What that basically means is the object will store all the information about your data. So the student will have fields like roll number, name, school attended, and all these things, and that is all the information is being encapsulated in the object student. That brings us to our second concept, that is abstraction. What abstraction is basically means that let's say we have an object which behaves in a certain way. Let's say a student, or it's a student, or it's a patient. Both of them will have some similar fields, like they're both humans. They have names, their age. So these are basically properties of a student as well as property of a patient. So we can abstract that into something called a human being. So the abstraction of all people is humans, because all humans will have a name, an age, something they do, how they survive, and everything. So that's how we abstract our data structures. We need not know specifically what the property means or what it represents, but we can abstract it into a certain kind so that we have we can that helps us exploit, because an abstracted thing can represent a lot more than it could otherwise. Let me give you an example. Yeah, yeah, bad examples. I'm sorry. Let's say we have a box which takes a simple input and gives a simple output. Input and output. Now, what's important to understand is this box does some process on it. Does some process on the input and gives us an output. So this is an abstraction of any sort of machine which you can imagine. Let's say a vending machine which takes in your money, gives out a coke, or let's say a manufacturing line which takes in raw material and gives out metal, or let's say a card punching machine which takes a card and punches the code into it. So we have abstracted the function of input and output into an object. We're not concerned about what the input is or what the output is. We just abstracted it. So the abstraction gives us something very important here, because the same model can be used to represent a lot of other things. And which brings us to our third important topic. Oops, my bad. सुनाई दे रहा सुनाई दे रहा Which brings us to our third important topic, which is inheritance. What inheritance does is, if you define a certain class, we need not keep redefining different classes or objects. We can reuse those objects and add properties onto them, which will help us quickly create newer and faster models. So let me give you an example. Let's say we already have an object called a student. Now, if there's a teacher who's learning in a college and if, let's say there's a PhD guy who's teaching as well as a research assistant, let's say. So, time for another bad example. Let's say we have a research guy. Let's say a guy who's doing his PhD, and he's teaching as well. I could create a new model for him, which would be like the course he's studying, what college he's studying at, what courses he's doing, what he's teaching, and everything. But what I can otherwise do is, I would already have a class for blues, all right, I guess. That's a teacher class. My bad. So, since we already have a class for a student, I can inherit from student and make a PhD class so that I can represent my PhD students. So, how that will go is, how that will go is, I take my student class as my inheritance model, and I put in a PhD guy, and I add the other properties. नहीं ठीक है यार, ये तो ही सुन. ठीक है. So what that does is, I've inherited from my student class. So all the fields like uh, inheritance. By the way, those of you who've read the inheritance cycle will find it really funny. But anyways, since I'm inheriting from my student class, I already have all properties of student in my PhD, which is what school he's studying at, where he goes, what he does, what's his age, how many credits he's taken, and all those things. Now I want to add the teacher related function, what courses he teaches, how much he earns for being a teacher, and all these properties I can add on to my inherited class. So I don't have to keep on redefining. Now I can take this PhD guy who's a student as well as he teaches, and maybe create a graduate research assistant or something like that. So that is inheritance. So these are the basic concepts of object-oriented programming. Yeah, and most object-oriented programming languages support these features: encapsulation, abstraction, inheritance, and so on. So I hope I'm not forgetting anything. Yeah, you'll come across some other terms like message passing and polymorphism and all these things. I won't want to get into the detail of those things now because they can wait for later. I'll be giving you examples about them, so don't worry for all those who are ahead of others. But for now, I think these are the basic concepts which guys need to understand to get down and dirty with Python and start coding. So what I'll do is I'll show you how these concepts break down into practical things first by examples, and then by using code, actual code. So I need to clear out my drawing board. Let's see how I do that. Basis how crash it. So let me take a simple class for an example. I would like to create my own class of students. Pretty boring. Let's go. Let's do something like what do we say? Let's model a telephone. Since my mobile is the first thing which comes across my face. Now this is my mobile class. So first, don't forget our concepts. I'm sorry I deleted the last slide, but I'd like you guys to keep that in mind. Now the first thing which we would like to think about when we're talking about a mobile is the data, all the data of a mobile. Now this is a typical way in which object-oriented structures are divided. One of them is the data and the other is the functions related to that class. Now this is just a general way of giving it. It's not the only way of doing it. So we'll take that route. We'll encapsulate all the data about the mobile in this object. So you need to refer to this object, this mobile, for all the data that you need. And something I'd like to keep you in mind is that this is an abstraction of a mobile. I've not yet specified what model I have or what make it is or what year it was produced in or so on. It's just an abstract model. and we need to bring a concept of instantiation, which I'll come back to later, which really concretizes object-oriented programming. So if I'd like to start, I'll call the data fields. The data fields of the mobile would be, you know, let's say phone number, company, make, make or brand for that matter, screen size, phone number, and uh, थोड़ा blur है क्या? I just got some live feedback that the font is very small. I'll try working on it. Just give me a second. I don't know how to modify the settings for this, so we'll have to live with it for now. Since I'm saying what I'm typing out, I don't think that should be a problem. You guys can pause, have a look, and since this is my first time, I'm very sorry if there are any problems. So, company screen size, make phone number, yeah, so on and so forth. And what I'd like you to focus here right now is I'm not specified anything. No company's been specified, no make's been specified, no screen size or no phone number for that matter. So what that means is I've abstracted all these properties of a mobile basically. And let me make the functions for a mobile. For all those who don't like yellow, I'm sorry. I don't have much color choice. Yeah. So these are the functions. Let's say change the color. The functions would be switch on, switch on, save a contact, save, click photo. Now, an obvious question that might be coming in your head is why don't I have a function called make call? Now, in my model, what is important here to understand is the way I've modeled a mobile. A make call would need two mobile numbers to connect two people. So I will come down to that in the next slide. But what I'd like you to understand is the data and the functions, they belong in a scope. Now the data of this mobile will belong to this mobile, where the functions for this will belong to these. Now I can define make a call in two ways. If I define make a call within the scope of mobile, that would mean that the call is being made from this phone and I need the phone number of another mobile number to make the call successfully. But if I define a global make a call, which is not a part of this function, which is not part of this class, that would require two phone numbers. That's why here I haven't defined my make a call function yet. I just want to deal with my mobile phone functions. And there are obvious advantages and disadvantages of defining the scope of functions. But for now, I will keep my call function global. I would like to keep other functions here. So if these terms sound too heavy, please drop a text. I'll freely explain it all to you. You can go over the video again as well. And yeah, so this is important. Now I'll come down to instantiation, which is the next important thing. Now let's say in the Hangout we have 10 people, 11 people. All of us have a phone. All our mobiles couldn't be represented using this class. So what I'd like to do is I'd like to create 10 mobile phones. Say M1, M2, M3, and so on. And iPhone. I know I'm a very big show off and an Apple fan, Gotta live with it. Now my mobile class can represent each of these mobiles. They'll have a unique phone number and so on and so forth. So M1, M2, M3 are instances of my mobile. So I have an abstract mobile class which can be used to represent M1, M2, M3. So M1 is an instance of my mobile class, M2 is a separate instance, and M3 is a separate instance. Now M1 will have its own set of data as well as function fields. M2 will have its own, M3 will have its own. And why I'm not drawing this is because I need a superclass to represent an iPhone. I'm sorry, I'm a very big Apple fanboy. So, okay, forget it. So what I'd like to now focus on is on an instance of a class. So let's say I take M1. Now, when I say company for M1, that means that's the local, that's the specification of M1. So I'd represent that as M1.com company, let's say. For those of you who are familiar with this, would understand this. For those of you who are not, I'd explain that this is the company of M1, which we have already abstracted in our mobile class. But M1.company is now representing this box. M1.company represents the company of M1. M2.company would similarly represent M2's company, so on and so forth. Now, functions M1.switch on would switch on M1, and M2.switch on would switch on M2, and so on. So that is about instantiating a class. Now gotta stop for a while because someone apparently lost us. ये इसे देख तो वापस जाके देख सकते हैं क्या? Start. याद रखना. Okay, I'll continue until I find. I think हमारा नेट क्रैक हो गया. अपना नेट गया. चल तो रहा सब. तो चल रहा. मेरा तो चल रहा था. फोन पे ये नहीं आना. तो फिर डेटा नहीं नहीं पागल है इतनी सी चीज के लिए डेटा का. बाकी सबों ने सुनाई देगा अभी. I'll just continue, so I'll cover up. Let's see, I'll cover up with whatever. So once you're done with instantiation, why this helps is, just give me a second. अब एक बार चेक कर अगर आ रहा है क्या. हाँ मतलब आराम से. हाँ. All right, have to go over instantiating once again. So what I'll tell you again is we have an abstract class called mobile, which is not representing any mobile yet. It's just a class. So what we do is we instantiate an a copy of M1, which gets all the properties of mobile. It gets company, screen size, make, phone number, switch on, save a contact, click photo, and so on. But it's a unique class called M1. Now M1 will have one second. Hello? Okay. हाँ
फालतू डबल मिनट लगेगा तेरा स्लो होगा
नहीं स्लो नहीं टाइम पास हो रहा है so
स्लो
so once we instantiate M1 is gonna get all the properties so we can refer to the individual properties of M1 so we can go like we can call M1 dot company or let's say I want to click a photo on M1 so whoops my bad what I do is M1 dot click photo understand so each M1 M2 M3 is a unique instance of my mobile class with their own set of properties their own set of functions and stuff so now we can manipulate all the information like let's say I want to change M1 dot company Microsoft bought Nokia so my Lumia's company M1 dot company changes to Nokia so I can find all the phones which have Nokia as their company and I can change it to Microsoft. Now you see what power that gives us. If I have say 100 instances, 100 phones, I need not go over it individually. I say all those mobile classes having a field called company equal to Nokia should be replaced as Microsoft, and my job's done. So that's the power which is given to us by instant like objects classes and instantiating them. Now, I would like to talk about how these classes interact because how these objects interact because that is what is more important in us to use our future things. So, let's say now I have a uh, oh no. uh, guys, you should get this terminology very strongly into your head. Let's say I have a class called mobile and an instance called M1, and I have another one called student and have an instance called S1. Now, my mobile is going to have its fields, but I'd like you to focus on one important field called user. So, the user field would need a student object, an instance of a student to be valid. Now, this is very important to understand. M1 has a field called user, which needs a relationship with a student for it to be valid. What that means is my mobile phone M1 is owned by a certain person, a user. So now, if I had a class called person, from which I inherited student, so my user field could also take person as a valid entry. Or let me correct myself, an instance of a person as a valid entry. So let's say I have a person called P1 and सो रहा है क्या? वो, अर्जित सो रहा है क्या? सोता करो भूख लगी मुझे भी चलते हैं खाने so let's say now we have a instance of P1 so my user if I've defined user to be of type person Now, what is important to understand is, as you've done in C, as you guys must be remembering, every variable, field, or something needs a type with it. So let's say I have defined my user to be a type person. So all the classes which inherit from person can be fit into user. Let's say I've inherited a doctor, student, teacher. All of them can be linked to my mobile ka user field, which will let them connect. So that is the power of inheritance. Whereas if I had said it had to be a student user, I could not have linked it to person user. So that is what the power is. So initially, let's say when we start off, we're not sure of how many different type of people we're going to have in a company. Let's say, so I define a generic class called person who's able to use a phone. So every user I'll be able to link to that. So this is very important to understand that here I'm linking an object to my M1 ka field, and that is the beauty because objects can have other objects as their fields, as their properties. Now, if I were to refer to user dot name, yeah, I'll give you extra points if you guess it right for what it's gonna return. So user dot name would return the name. Oh, my bad. What we need to do is m1 dot user dot name. So pretty obvious. This will return the name of the user of M1. What that basically means is our M1 instance has a user, a property. That user is an instance, it's an object, which so you can replace basically this would essentially mean S1 because that's the connected user. M1.S1.name. What will be the name of the S1 guy? So these are how objects are interlinked and how they're connected together and how they work together and so on. And just one small before we finish, I'd like to give a small before we finish on the slides. That is, I've just been talking about data fields. The same goes for functions of things as well. Now let's say I had a I had a I had a thing called memory. Like, let's say my M1 had memory and it is stored around 10 people, 10 students' phone numbers. So I have a function say I'm running out of colors here. I have a function say M1 dot tell name. Now how this is different from a data field is that this guy needs an input. He needs an input from you and it will give an output. Now, what is important to understand is tell name belongs to M1. So, if I'm giving an input that tell name of the first guy in your memory, that is my input. Tell me the name of the first person in your memory. Now, M1.tellName would tell me a different thing, and M2.tellName would tell me something else because the function belongs to M1. So, again, the concept of encapsulation brings in here because every data, every function belongs to its own user, its own object. So, when I say M1.tellName, M1.clickPhoto, M1.showPhoto, M1.clickPhoto is going to get stored in M1's memory, not M2's. So, that's important that there you use the function of the object based on what you're referring to. So I think this is enough for the slides. You guys should go over the videos. Text me any doubts which you have. Keep studying, get the concepts into your head, encapsulation, inheritance, and all these things. Wikipedia OP helps, but it gets a little too technical. I hope these examples weren't too difficult. I'll what I'll do now is I'll show you a few Python programs to actually show you what I've been doing until now. My coding's a little rusty and I'm a little sleepy, so please, I might just not be very. So the way a class is defined. Okay, let me do something else. Class person. Just give me a second if you guys are getting bored. I'll be explaining this to you. Oops. So what I basically did in this code was I defined a class called person, and what I did this thing was this is def init self comma name. Nothing to get worried about. The def init basically defines a function, and this is the init function. That basically means that whenever you create a new person, this should automatically execute. And what it does is it does self dot name is equal to name. Now, what's important to understand is the def init self name. Let's not get into technicalities here. I'll be explaining all this later. But just focus on this for a moment. P1 is equal to person dot is equal to Harshit. So person is the new person instance of person which I've created, and it requires one argument, that is Harshit, which is here name, which I need to put in. The self is a technicality. I'll explain that later. What that does is self dot name is equal to name. The small name represents the name that you fed as the argument, but the self dot name means that's the name of the new person who's going to be instantiated. So P1 is equal to person Harshit means that I've created a new person P1 with the name Harshit. Now, if I were to do P2 is equal to person, just pick up a name, man. Oops. So you see how I'm using the properties of person to I'm using the field self dot name. Every person has their own name. Now, if I were to, I'll give you a small example of inheritance. You guys don't need to understand this completely. I just wanted to show you how it works out so that your interest doesn't get class student person. Not sure if this works by the way. So age student. Yeah. So just give me a second. Whoops. My bad. Yeah. So what I'd like you guys to focus on here is what this code did is I created a class called student, which has inherited from person, and I created a field called age for student. Now, what you have to understand is the age field is unique to student. It's not there in person, but I didn't need to create a name field here, and I created a function for student called def is adult, which takes self. That is technicality. I'll explain that later. Now, if self dot age is greater than 18, that means if the age of the instance of this class is greater than 18, print the name, which I've not defined here, but that has been inherited from person, is an adult. Pretty handy function if you want to check if a guy should be going to an adult movie or not. But yeah, we talk about that later. So what this line does here is S1, I create a new student. S1 is a student amount. S1 dot age, I set its age to 20, and I type is S1 adult and print S1 dot age, which is pretty obvious. So I think that's all for today. I hope you guys enjoyed. I haven't taken too much time, and we'll be putting up the assignments in a while. So I'd ask you to get started. I didn't cover decision statements and looping statements and all those things because all of you guys have done CP, and the technicalities of all that always takes away the charm of coding in a while. So I guess you guys can do that on your own. It's not too difficult. You just saw me type out an if statement. All those things I can help you out whenever you need. That PDF is more than enough. So finish the assignments until now. I'll be putting up the class assignment for class and objects, which won't be too difficult. Go over this video and have fun. We'll continue.